Welcome to another lecture in CIS 5. Now this lecture is going to deal with the topic of data types. Now what is a data type? A data type is like a container that can hold like sets of data. We define each collection of these pieces of data with this tag, and that's what gives it a set of operational rules to follow. So what's going on behind the scenes here is that you actually are opening up a memory address, and then what you're doing is you're giving that memory address a name, because it's much easier to deal with a name than it is changing memory address. So you define it here, and then you open up a container that will hold a piece of data that matches the data type that you've declared. So in this case here, this is 30 is the value that we're going to be storing inside of my var. Now what is that? 30 is actually going to represent an integer with our data type. This is the first data type that we're going to learn, and it's one that we've actually already have seen. Now remember when you were typing in your basic, what we're going to call template for everything else that we're going to be doing in this class, that basic template, and that included the main function. The main function started this way. It started int main, and then you had the body of the function and the return statement. And you saw that the data type int was put in front of main, and now you know that that was a data type because it signaled that at the end of this, the return, a whole number will be returned back at the end of this here. And this actually resolves just down to the exit or error code. In this case, it's running successfully. So the int stands for integer. It holds whole numbers, and it has a range that it can operate within. It's arguably the most common data type used. Now it's not the only data type that's out there. In fact, there's many other different data types, and there's different ways to implement the data types as well. So when this was first concepted, it was all done in a time period where size and limitation was very relative to what we were imagining at that point. And since this has evolved over decades and decades since this was really implemented, we've found that we're not too concerned with the size of the data types that we open now. This whole notion of what happens to our variables if we exceed their number range, because they do have limitations. Just like any other container, or in this case here a suitcase, has a limitation. You can't put your entire closet inside that suitcase. So do these data types. Now the int has a number range that it must stay within. Now this number range, here is the number range that's actually printed with the standard way of declaring the int. It opens up 4 bytes of memory, and then it has a number range from -2,147,483,647 in the negative space to the positive inverse of that. And you'll see there's other data types too. They also take up footprints of memory, and they have very large range or very small range. In this case here, this data type only has 2 possibilities. So let's talk about this int again and kind of show you different ways that it can be declared. It can be declared as a short int. So if you were to place the word short here in front of the int, that would signal that this is going to be a short int, and in which the number range would be drastically reduced, and it's only half the size of memory. It's 2 bytes. Now to take this into context here, we established that 8 bits is a byte. Okay? And then after that you have the kilobyte, and then the megabyte, and then we know how many megabytes equals a gigabyte, and then from gigabytes, terabyte. You see, we're operating in a very, very large capacity now, and that's primarily due to things like Moore's Law and just our development throughout the years. We've been able to engineer these very, very high capacity devices, and our computing has gone through the roof as far as power from when this was originally concepted. So it's much more common nowadays to focus on program stability, right? That we don't exceed the bounds of our container, rather than how much does this container hold in footprint of memory. So there are different ways to do this. You can declare it as a short. You can declare it as a standard int. And back in the day, you could also institute a long version of the int. Now, the long int was a expanded number range from where it once was, which is around, I believe, depending on the operating system you're on, is around only 32,000. So if you had a number that was bigger than 32,000 or negative 32,000, you could exceed that container. That's very easy to do. So the long was a way to get around that, and then you had the long, which was 8 bytes, and this expanded the number range because it was bigger and it was able to hold more things. Another version of this here that you're going to find is the unsigned int. There's a difference between signed values and unsigned values. An unsigned version of the integer can't take negative values. Something very interesting happens with that as well. Instead of having a negative range, all of that space that was dedicated to the negative size, here, in this case, there was a negative 2 billion, all of this would be transferred and added to the positive range. So instead of having negative 2 billion here in both directions, it would be added together. So this would be somewhere around 4 billion 200, and it would just add that to the positive range, and it would start from 0. So the range would start from 0. This is great for things that do not require negative values. For instance, if you're trying to represent something like time, time will not be negative here unless we have a DeLorean. The next data type that I want to talk to you about actually resides in the floating point or precision type of data. Now, what this type of data is it holds floating point numbers, fractions. And the float is going to be single precision, so it's 4 bytes. It's also 4 bytes, just like the int. Now, what is this perfect for? It's perfect for representing things like currency. If I tell you to represent $1.50 in cash, you would probably be tempted to put 1.50 or 1.5. Perfectly viable. Problem is that the int will not be able to hold that. It will truncate that, and truncation simply means to cut off, to omit, to remove that from the part that's stored here. It would only simply output 1. So everything that has a decimal or level of precision there is omitted, the int. The float will track all of that. So it's something that we will use anytime that we want to use floating point precision, and it has a number range as well. Now the float has a range, but it's not a very large range. The double has even more points of precision. The double has roughly double the amount of precision that the float does. And it's 8 bytes. So we go from 4 bytes to 8 bytes. So it holds a lot of levels of precision. Why would you need that much extra? Well, if you needed to represent something that had a lot of decimal places, past, say, 6 places or so, you'll want to use a double. There's also a data type called the bool. What is the bool? Well, this is the Boolean. If you follow any concepts with philosophy or mathematics, or if you've heard of a guy named George Boole, this is a very, very fundamental data type in computer science. This is what represents the true or the false, or the 0 or the 1, the on or off. And what this allows us to do is it allows us to represent things, conditional things in our code. We'll use this a lot in the future. We can ask questions. We can ask if things are true or false, and then react depending on the answer. So this is a very, very important data type to us, and it will be used a lot in the future. Then there's the char. Now what the char does is allow us to store an individualized character. The way that we declare these characters is enclosed in apostrophes. So you can have a variable and just wrap it in these apostrophes. See this here? And you could store that inside of a variable. It uses 1 byte of memory, and characters are represented internally by these numbers that represent the ASCII character set. If you don't know what the ASCII character set, you can access any one of the characters via the keyboard. So it's anything that you can access via the keyboard. There is a chart that you can look at. I'm sure if you just type this into your internet browser, the ASCII table, you can find that table and it will show you every character that is possible. Now, we just talked about how you can store a single character into a variable. What about if you want to store an entire series of characters, like a sentence or a name, a username, something like that? You can do that, but not with the char data type. It will only store 1 character. Enter the string. Now, the string was something that was added on to the language. C++ was added because there was a way to store text, but it was using a series, a collection of chars. And imagine if you had to store characters, 1 character at a time, inside of a different variable. That's very tedious. So they came up with the concept of the string, and the string allows you to store a series of text, a series of these characters, inside of 1 variable that you can track without having to use any things like arrays or any structures like that. So to use a string, the prerequisite is that you must include a new library. This new library is the string. So you have to type this at the top of your code, just like so, in order for this to work. Now subsequently, you also need using namespace, but since you already have that, this will work flawlessly. If you did not have a namespace here, or if you did not have this here, you would have to put the words std in front of any time you use this here with a scope, something called a scope resolution operator, which is 2 colons in a series, in order for this to work. Since we're going to be following a standard layout from the textbook here, we're going to use the format of including this library and making sure using our std namespace is also included in the header of our code. Now, to use a string, we type the data type. So just like we would use with bool, char, int, float, double, any of these other data types, we simply put string, and then we name that string. In this case, I've just called this my string. And then, instead of the apostrophe, we use quotations for the string. And that will store, this is my string text, and the punctuation and the white spaces, everything here inside of these quotes will be now stored inside of this variable. So if I were to write a cout statement right below this, if I just said cout my string, this will print. So going over how to declare a variable and use it properly. Step 1, we use a data type, which is kind of like what we'd establish as like our tag. We say what kind of data type it is to define the data set. And then we're going to give it a name. This is called the identifier. So just like with the string we had my string, that's the identifier for that variable. Then we can give it a starting value. Okay, now that starting value may actually be part of the initialization process. So right when you create the variable, you can assign it a value. So just like I did in the previous example, this here is an initialization. I created a variable and then I immediately assigned it to something. Or you don't have to assign it from the start. As long as before you use it, you give it a value somewhere in your code, and there's no other way to access it without it getting a value first, you can do that. And that will qualify as giving it a starting value. After that, you're ready to use it. You can then call it by the identifier from there on out throughout the rest of your code, and you can use it as you will. So here's some things about the identifier. The identifier, again, is the name that's given to the variable from the programmer, so you can name this whatever you want, but there are a series of rules. The variable names must begin with a letter or an underscore, and they can even be used as a $sign. But don't use the $sign because Java uses that, and you don't want to mix this around. Because chances are, if you do continue in computer science, you will also learn the Java language. That will really mess with your head. So after the initial letter, the variable names, or could be underscored as well, they can contain the digits 0 through 9 after the first letter. That's perfectly fine. It just cannot begin with a number or a digit. Okay? No spaces or special characters are allowed in these variable names. What is a special character? Something like the @ something like the exclamation point, something that's a special character. Could be something that's accessed by an alt key. The variable names can be of any length, but you should try to keep them concise. You want these to be very easily read, easily accessed, and having a paragraph that will serve as a data type name is not good at all, and you want to refrain from that as much as possible. On the other hand, you don't want to have a variable that's like X or something that's too short. Lastly, you cannot use a C++ keyword for a variable name. I believe there's a list that is posted, and you can refer to that to see what the C++ keywords are. It's also in chapter 1 of the textbook, so you can see what that looks like. Okay, so just as I was saying, X is a terrible name for an identifier. Why? Because it could mean anything. In fact, X is traditionally used in algebra to represent something that we don't know. It's a variable, something we don't know. So if we use that as something to represent something we don't know, shouldn't we know what the identifier is doing throughout our code? So it doesn't really make sense too much. And instead, we want to use something like, if X is supposed to represent the item amount, call it item amount. That's a much better name for it. It should always start with a lowercase for these type of variables that we're going to be implementing. That's just going to be standardized form here. Starts with a lowercase, and then any subsequent word, so this is word 1 is item, word 2 should begin with an uppercase. So again, names can't have spaces. They can have underscores. And the first character must be A to Z or an underscore. Characters after that can be digits. That's perfectly fine. So if this was like item amount 9 or something like that, you can have a 9 on the end of it. That's perfectly fine. Just can't start with a digit. Now, this sort of concatenation between these two words here by having the uppercase makes it A, easily read from programmer to programmer. The second thing that it does is it institutes this standard here, which is called camel case. So camel case is something that you can look up just to give you a little bit more insight into naming the identifiers and why it's a standardized habit. So after you've given the variable a data type and an identifier, you can then assign it. So here is a way to assign it inside of the declaration. You can use the equals sign. Now, the equals sign is meant at this point to be read as the assignment operator, okay? So I'm going to call it the assignment operator. Now, the reason why I do this is because it will confuse you guys when this is used for something else later down the road as well. So in this case here, I want to call this the assignment operator, and I don't want you to read it as equals to. For instance, the data type int with the identifier 1 is equal to 5. I don't want you to read it that way. I want you to read it this way. 1 is assigned with the value 5. It would be much easier if you read it as that way instead of equal to. That way, when there is a different assignment of this operator, it doesn't confuse you guys. So a little bit more about initialization, which is to give a variable a starting value right from its declaration. That's what initialization is because memory can be a messy place. When you open up this container, anything that is left over is then assigned to that variable. What do I mean by leftover? Well, when memory, it releases a variable, meaning when it's done, that function ends or your program ends or whatever have you, and then a piece of programming comes along that says, hey, I'm going to create a variable. It grabs an available address, and then it hands you the key to that, which can be identified with the identifier, and then you can place your values inside of it. So think of it kind of like a hotel here. So you go up to the front desk and you say, I need a room. And then they look on their chart to figure out which rooms are not occupied, and then they can hand you a key to that. And that key can be like your identifier. So you can identify, okay, this is where my room is held in memory, or my hotel. And then you can go and put your things in there, and you can reside in that. Now the problem is that say if the initialization process did not happen, for instance, the maid did not come in and prepare that room, whatever was left over from the last person that was in there will be affected in that room. So this can lead to some really weird behavior in our program. Imagine if a value 2 or some huge long, which is much more likely to happen, some huge long number like -5 million something, whatever, if that's left in that memory address from the last program, we can have a lot of weird behaviors happen because of that. So your compiler will actually throw an error and it'll say a variable, whatever your variable name is not properly initialized. It will actually throw an error because you've tried to access this variable in your code without giving it anywhere in your code a value before it tried to access it. So for initialization in C++, you actually can initialize it from the start by using the assignment operator. So from the start, in the declaration of this variable, you can give it in a starting value. Subsequently, you can also do this by declaring it, putting a semicolon here, and then saying 5 is assigned with true, semicolon. And that will also initialize that variable because no other statement is trying to access 5 before I give it the value. Okay, so let's talk real quick about some literals. And what is a literal? A literal is a value that are constant. Programmers also refer to these as hard-coded values. So in your last assignment, where you had to see out a shape or a pattern of all of these different symbols or shapes, those were literal values. You weren't using a variable to output all of those to the screen. So when we say things like int my var is assigned with the value 3, the 3 is a literal 3. It doesn't represent something that's changing at all or anything. It's a constant 3. It never changes. Versus if we had something like new var is assigned with my var, this is a variable. This is not a literal. Just like if we have a cout statement that says, I am also a string constant here, in quotations, this is a series of text that is a literal text. Right? This is a string literal. And I keep hitting the wrong key here. Here, this string str is assigned with a literal hello. This is a string literal. This cout statement here, we were couting str. Str is a variable. Now the variable holds a literal, but this can be changed at any point in time. So this is not a string literal, whereas this is. So the literal is a hard-coded value that will be a constant value. And the constant value will either be the straight value itself, here, okay, or it will be the value not attached to a data type or a variable at all. So it will be just the 3. We'll see that a little bit later. So for multiple assignment, now when you create your variables, you can actually assign the variables to each other, or you can assign a lot of them inside of one declaration. You can actually declare an int, and on that same line you can declare multiple versions of that data type. I'm going to open up Visual Studio real quick, and I'm just going to quickly show you this. You can have, say, an int. Make this a little visible for you guys. You can have an int, and you can call it A. You can give A a value. So I want to get A. I'm going to give A1. Okay. Now, if you wanted to create another variable, you probably would do something like this. B, and I'm going to assign this to value 2. Okay. And this works, but there's also another way to do it. So if you had to create 5 of these ints, you could also do this as well. Put A, then you can do B. You can even give it a value if you want. C, and so on, until you're done. And that will create these variables here, which are terrible variable names, by the way. And you can all assign these on the same line, which is the declaration line here. Okay? And they will all be of the same data type. It's very important that you use the comma here and not semicolons. There's also another formatting tip for this as well. When you have multiple versions of this across the various comma lines here in between, you can also line them up vertically like this. And these commas here will denote that it is still continuous, that it's going to use the data type at the top of this here until it reaches the semicolon, which says, okay, now I'm done declaring all of these variables. Once they're declared, you can set and you can assign each of these variables also as well using the assignment operator as many times as you want. So for instance here, this literal 25 will be assigned to the variable D, which then D, which holds the value 25, will be assigned then to C. C will be assigned to B, which again holds the value 25, and then B will be assigned to A, which will now also hold the value 25. So the value 25 keeps getting copied in all of these variables here, and that's multiple assignment. Now constants, I don't want you to get constants confused with literals, although literals can be used to represent constant values. We have another way to represent a variable and have that be a constant to where it cannot be changed. So say for instance here pi, which is probably the most common constant example used throughout the textbook, 314, we can represent this as a constant float inside of our programs. So if you put 314, which we'll just cut off pi at the second precision spot here, we can turn any data type into a constant if we just put the word const, so it's the keyword const, we put that in front of the data type. So as soon as you do that, you can no longer, throughout the rest of the code, assign a value to pi. If you try to use the assignment operator after the initialization here, you cannot do that. It will throw an error and it will say this is a constant and cannot be changed. It was very useful. Okay, I'm going to go ahead and show you inside of Visual Studio. I'm going to launch that here. I'm going to show you how these data types are declared. just like they were in the slide. The int uses the int. If you were to use a variation of, say, like the int, you were to have it be a short int, you would simply use the keyword short or long in front of this, in front of the int. Since we're not really worried about that, I'm just going to go ahead and show you from here on out the data types and how they're declared. So the int next needs an identifier. I'm going to call it number. And then I can set number and assign it to a value. Now it's very important that I give number a value before I try to actually print this out to the console. So for instance here, I print this out. I'm going to move my console window over here. I see 5. That's perfect. That's exactly what I wanted. But if I were to move this up, the assignment happens after I'm trying to access it. Okay, after. Now if I do this, I get a build error. And this build error down here tells me that the uninitialized local variable number is used without giving a starting value. And that is because I'm trying to access it before it has a value. So that's dangerous. So if I'm going to declare a variable and then turn right around and give it a value, it probably makes more sense just to do it up in its header. Okay, just going to be the number declaration. There we go. Okay, the next data type that I'm going to declare is going to be the float. The float will hold floating point precisions. I'm going to call this my float because I am not creative. Now I'm going to assign this with a floating point value. I'm going to put 123.124. And then when we're all done, semicolon. The next was the double, and the same thing with the double. Okay, I'm going to put 34.6565534. We can hold a lot more precision. Sorry guys, I'm still getting used to my keyboard here. Okay, double. Alright. Then after that, talked about the bool. What does the bool hold? The bool holds a true or false. So it's great for asking questions like, is the light on? Then we can say, by default, yes, it should be on. It's assigned with the value true. Lastly, we had the char. Or is it lastly? The char was able to hold a character. So I'm going to just call my char. And the char needs to have its declaration wrapped inside of these apostrophes. Why? That's so that it says that this is a character and not a number, or a value rather, that it's going to try to use in a mathematical expression. It's simply the ASCII character representation of that character. So here we could put 5, which is not actually a value 5. Sorry guys, I really want this keyboard to work. I think it's the perfect keyboard. I just got it, and I'm still getting used to it. But it's a lot more compact. But I'm using brown switches on it, and it's really nice. It's just a lot smaller than I'm used to. So I'm trying to make this work here. So hopefully we'll improve. Okay, so again, this is not a computational number 5. This is the ASCII representation of 5. Okay, so we can do no math with this here. This is simply just a representation of that. It's a character. Last, we have string. Now, in order to use string, we need to do something. And that something is, we actually need to make sure that our namespace is here. And we need to include the library string. Okay, that must be here. Otherwise, we have to then redefine it with saying that it belongs to the std library every time we want to use it. That's annoying. We don't want to do that. So we're going to use the include for library in the preprocessor up there, and then we're going to have string, and then I'm going to call this str. I'm going to initialize it with this is a string. Now the string is wrapped in not apostrophes, it's wrapped in quotations. So much like you use in your cout when you give it a literal string, you do the same thing with the actual string data type, and that's also used with quotations. So hopefully this helped. I'm going to go ahead and end the video lecture now, and the next video we will iterate on this and show you some expanded stuff from this chapter. Thanks, guys.